We're going to take a look at a workflow to improve the performance of a part that has a large number of perforations arranged in a pattern. This is a contrived part that I made, not any specific customer part. And I am going to start kind of working backwards. Obviously I'm at a result, and I'm going to inquire element, and we'll get in on this cylinder, and we'll see that it actually is a cylinder, which is preferable for downstream operations like a cam system can find a cylinder. If that were a B-spline surface, then it would be difficult to locate because there is no center line. So I'm going to work backwardly, as I said. So this last subtract operation is probably the worst performer. This pattern is a little less dense than what I've seen, but I'm going to suppress this. And the benefit of having it suppressed is you can now work with a little bit better performance as you develop your design. So first I started with just a simple protrusion to make the half pipe, and then I laid a sketch. Now the sketch is pretty much the heart of it all, and everything is derived from that. Again, these is just contrived, these are just made up numbers. So I took advantage of a new capability in Solid Edge, being able to pattern elements within a sketch. The reason I like this is I can see where the holes are going to land, and I essentially made another rectangle here that encompasses the holes where I would like to omit the perforations. So I just did one for this demonstration. So essentially I have a couple of master circles where the two kind of master holes are going to be. I drew a little line there, and you'll see in a second why that's important. And then the rectangle represents kind of the unrolled definition of this pipe, even though we're not really going to unroll it. What we're going to do is wrap it down. So let's accept that. And then we simply wrapped that outer rectangle down, which is kind of the perimeter. It's going to be the driving geometry for our pattern. So that's been wrapped down. So at this point we can kind of just hide the sketch. So I've wrapped where this is going to be the defining shape for the pattern, and this is going to be what is going to be omitted in the perforations. And this is really just the holes. So I just decided to break it up into 3 separate wraps so that we have the ability to hide and show them conveniently. That's really the only reason I did that. So then the benefit that I found is if we use a multi-body approach. So essentially what we did was we did add body, and at that point I made, and if we right click here and say show body features, and actually see that these protrusions, which are just the green items here, so these 2 protrusions are in a separate body from the main design body. And the benefit is, as you pattern those protrusions, they don't interact with each other, so there's no Boolean happening at that point. So the pattern is very fast. When you run this pattern, it's very fast. And so to be able to remove some of the perforations, again we used multi-body, and essentially made myself a body that's a purple color. It's a construction body because it's going to be a tool for a Boolean subtract. So we essentially cut away these little cylinder bodies using this purple tool. and again, happens very quickly because the purple tool completely encompasses the cylinders, and the performance seems to be very good. And the pattern, I found the pattern along curve to be really useful here, because you can pattern in kind of this circular way, but in two directions, essentially linear in one way and kind of circular in the other. So if we take a look at this, if we edit definition on this, essentially the first curve is this green, which is, if you think about it, it's the same exact length as the square flat rectangle that we defined back in the sketch here, because that was wrapped down. So that is that. And then we used the probably lesser used step of the pattern along curve. So we defined the other segment, and each of those, for simplicity, are 1/2 inch. So we're patterning these two protrusions, which are here and here, using the pattern along curve that follows this direction and the other direction. And that is a way that you can make what is you'd like to think of as a rectangular pattern that's derived from this sketch. And then we simply subtract away using this purple kind of a tool the cylinders where we'd like to leave them, which again is very fast. And then optionally, you actually could stop here. You wouldn't need to show this in the drawing. You could optionally show any of these in the drawing if you wanted to. And you could make a drawing out of this information, and this is enough to actually, at least with our CAM system, NXCAM, we'd be able to make drilling operations using that separate body, which I've called holes. So that is enough information to create drilling cycles in our CAM system. So if you then actually needed to have this perforation done for maybe flow analysis, you would simply unsuppress, you would save your file. Knowing that this could take a little bit of time, you would just do it at the end of your design cycle, and you would just simply unsuppress this last subtract, which subtracts the holes. All those cylinders are the tool, and they are then subtracted out of the original design body. And certainly that will take a little bit of time. It's pretty fast on this small demonstration part because the pattern's not too dense. But there's our finished component, and I think a pretty good workflow to achieve that results. I'd welcome any feedback or thoughts, and we could go over this in a live session if you like.